You just spent hundreds on a custom CNC part. The machining is precise and perfectly dimensioned, but when it arrives, it looks like it was chewed up by a robot. Those ugly tool marks aren't just an eyesore, they're a ticking time bomb for rust and friction. Today we're going to discuss the various surface finishing for CNC machined part. By the end of this video, you'll know how to choose the right finish so your part doesn't just work, it lasts. Before we dive in, quick visual. Side by side, an as-machined aluminum block with visible cutter lines versus a deep blue anodized part that looks ready for display. Big difference, right? Let's unpack why. Surface finishing is about two equal things, aesthetics and survival. Think of an as-machined part as an unfinished story. CNC leaves cutter marks and microscopic peaks and valleys. Those tiny imperfections trap moisture and grime, speed up corrosion, and increase friction where you don't want it. So finishing isn't just to make a part pretty, it's to make it reliable. Here's why finishing matters. Corrosion protection. Most metals are naked to the environment without a protective layer. Finish equals shield. Functionality. A surface finish can lower friction, improve electrical contact, or make a surface biocompatible for medical use. Customization. Want your brand color? Or a matte tactical look? Finishes let you turn a silver block into almost any look. Okay, now that you know why, let's look at how. There are three broad families: mechanical finishes, chemical electrochemical treatments, and coatings plating. Each one solves different problems. Mechanical finishes, the power of physical force. It uses friction and media to erase the machine's mistakes. Here are some examples of mechanical finishes. Bead blasting. You spray tiny glass beads or media at the surface with compressed air. The result, a uniform matte or satin texture that hides machining lines and creates consistent light reflection. It looks clean and industrial. Pro tip, mask your holes and critical dimensions. Blasting can slightly change tolerances if media gets into recessed features. Polishing, this is the mirror finish. Buffing wheels, compounds, elbow grease. Great for brass and stainless steel. Polishing reduces surface roughness dramatically. That's why luxury goods and surgical tools get polished to a mirror shine. It's labor-intensive, but sometimes it's the only way to meet aesthetic or hygiene specs. Other mechanical methods, you'll see tumble finishing, vibratory finishing, and sanding. They all rely on abrasion or controlled impact to smooth peaks. Use them when you want a consistent texture across a batch without changing the metal chemically. Mechanical finishes are fast and tactile, but sometimes you need to actually change the metal at a molecular level. For that, we go chemical. It changes the metal's surface with chemistry to create real protection, color, or hardness. Here are three common methods. Anodizing, the king for aluminum. Type 2, standard anodizing, creates a nice oxide layer that dyes beautifully, that deep blue, red, black, whatever you want. Great for color and corrosion resistance. Type 3, hardcoat anodizing. Think of this as armor. Hardcoat produces a thicker, harder surface that dramatically improves wear resistance for sliding parts or harsh environments. Passivation for stainless steel. Passivation isn't just cleaning, it's an acid bath that removes free iron from the surface and encourages a protective chromium-rich oxide to form. For stainless parts used in food, medical, or outdoor applications, passivation dramatically reduces the chance of rust. Anodizing film, mainly for aluminum, a cheaper, fast option that creates a thin conversion layer. It provides corrosion resistance and, importantly, keeps the surface electrically conductive, unlike anodizing, which is an insulator, good for electronics housings where grounding matters. So chemistry can protect, color, and harden, but what if you need to actually add material instead of just changing the surface? That's when coating and plating come into play. Coating and plating actually add material to your part, giving it extra protection, color, or special properties. Here are three common methods. Powder coating. Imagine bulletproof paint. Dry powder is sprayed on and then cured in an oven around 200 degrees Celsius. The result, thick, durable, high-impact finish that resists chipping. Great for housings, frames, and anything that needs color plus toughness. Note, powder coat is thicker than anodize, so tight tolerances and threads may need masking or post-machining. Electroless nickel plating, a secret weapon for complex geometries. Because it's a chemical deposition, it coats every nook and internal bore evenly. No line-of-sight limitations. Electroless nickel gives uniform thickness, excellent wear resistance, and good corrosion resistance. Electroplating, gold, chrome, copper, used when you want conductivity, wear aesthetics, or specialty properties. Electroplating can be beautiful, but beware. Some plating processes involve hazardous chemistries and require environmental controls. So how do you choose the right finish? Let's simplify. Match the finish to what you actually need. Need color, anodizing, or powder coating? Need durability or wear resistance? Hard coat anodizing or electroless nickel? Need cheap and fast? As machined, if tolerances and environment allow, or bead blasting for a quick, tidy look. For medical and food grade, polishing plus passivation. Need uniform coating inside blind holes or complex shapes? Choose electroless plating. Need conductivity preserved? Skip anodize or use allodyne film or plating. Here is a practical example. Say you're building an anodized smartphone frame that gets pocketed and scratched. Type 2 anodize gives great color and corrosion resistance, but not the ultimate scratch protection. If you need extreme wear resistance, for example a sliding rail, go with Type 3 hardcoat or add a thin electroless nickel layer, depending on requirements. Remember, finishes cost money and add lead time. The right choice is all about balancing cost, performance, and how the part will actually be used. Surface finishing is more than style, it's survival engineering. Whether you want a mirror shine, a deep dyed color, or an invisible layer of armor, the right finish turns a precise but vulnerable machined part into something that performs for years. If you're looking for a reliable manufacturing partner, RapidDirect provides one-stop manufacturing solutions tailored to your budget and performance needs. If you found this video helpful, don't forget to like, comment, and subscribe. We'll keep bringing you deeper insights into manufacturing, material science, and real-world engineering.